Hello students, today we are going to discuss exponential growth and decay. Let's take a look at the parent function. We have y is equal to a times b all to the x minus h power plus k. So let's go ahead and define what each of these variables mean. Just like in any other function, k tells us whether or not we're going to go up or down. If you have a positive, you're going to go up. And if you have a negative, you're going to move down. H, just like in quadratic function, is opposite of your intuition. So if you have a positive, that means you're going to go left. And if you have a negative, that means you're going to go right. B is our base, and this tells us whether we're going to have a growth or a decay. So if B is greater than 1, you will have a growth. If B is in between 0 and 1, you will have a decay. A, just like in any other function, if A is greater than 1, you have a vertical stretch. If A is in between 0 and 1, you have a vertical shrink. If you have a negative out front, that means that you are going to reflect over the x-axis. Now let's take a look at some examples of transformations. If I give you f of x is equal to 3 to the x, and then I transform it to g of x is equal to 3 to the x plus 2 minus 4. First off, I want to tell whether it's a growth or a decay. Well, my b is greater than 1, so I know this is going to be a growth function. It goes plus 2, so that means I'm going to go left, opposite of my intuition, 2. And then minus 4 would tell me I'm going to move my function down 4. If I look at this next one, I have f of x is equal to 3 halves x, and then I have g of x is equal to a negative 3 halves x plus 3. First, I need to tell whether it's a growth or a decay. At first, you may look and see a fraction and think automatically, oh, this is a decay, but be careful because 3 divided by 2 is going to be 1.5. So b is still greater than 1, so it is a growth. If you look, you have a negative out front, so you're going to have a reflection over the x-axis. And then plus 3 is going to tell us we're going to go up 3. Here's an example of what a growth and decay graph would look like. For our decay, remember the b, or your base, is in between 0 and 1. So right here we have our base of 1/2 raised to the x power. And if you notice, you have a horizontal asymptote at 0. Then if you look at our growth, our base, once again, is greater than 1. So greater than 1, so that would be our base of 2 raised to the x power. And you have a horizontal function, a horizontal asymptote as well. And if you notice, the decay goes downward and the growth goes upward. Now let's look at some applications of growth and decay functions. If we have a simple interest or growth, that means that our value or amount has added value only once per year. So the simple interest formula is A is equal to P times 1 plus or minus R raised to the t power. P stands for the principal amount, so in other words, that's the starting amount. R is the annual rate of interest. You will typically see this in your problem as a percent, so you're going to have to turn it into a decimal by moving it to the 2 places to the left, the decimal 2 places to the left. T is time, typically in years, and then A is the amount accumulated after in number of years, including interest. We will also see compound interest or growth. That means that the value or amount added value has been added multiple times throughout the year. Interest is paid on any previous interest accumulated. So the compound interest formula is A is equal to P times 1 plus r divided by n raised to the nt power. P is still the principal amount or the starting amount. R is the annual rate of interest as a decimal, so you're going to have to turn your percent into a decimal. T is the time in years. A is the amount accumulated after in years, including interest. And N is the number of times the interest is compounded per year. All right, let's look at an example of this. It says Brad invested $2,400 in a 3-year CD that pays 4% compounded annually. How much is his investment worth at the end of 3 years? Well, because we're only compounded annually, we know that that's once per year, so we're going to use the simple interest formula, which is A is equal to P times 1 plus or minus R raised to the T power. So let's go ahead and plug in the things we know. We are investing $2,400, so that is going to be our principal. Our rate is going to be 4%, which turned into a decimal is 0.04. And then our time, we're doing it for 3 years, so our time is going to be 3. So if I plug those in, I have 2,400 times 1. We are going to make more money, so it's going to be plus, and then our rate was 0.04 raised to the 3rd power for our time. If you plug that into your calculator, you will get $2,699.67. For example number 2, it says an amount of $1,500 is deposited in a bank account, an annual interest rate of 4.3% compounded quarterly. What is the balance of the account after 6 years if there are no withdrawals or additional deposits? Well, it tells us that we are going to compound quarterly, so it's going to be more than once a year. And when you think quarter, you need to think 4 times per year. So that is going to be your N, how many times you are doing that. So your N would be 4. Your P, your principal, is 1,500. Your R, your rate, is going to be 0.043 because we turn that into a decimal. And it says after 6 years, so our time is 6. So we're going to use the equation A is equal to P times 1 plus R divided by N raised to the NT power. So if we plug these in, I know my P is 1,500 times 1 plus my rate, which is 0.043, divided by my N, which is compounded quarterly, so it's 4 times, raised to the 4 times 6, which is our time. If I plug that into my calculator, you should get $1,938.84. And our last example says, Judd wants to purchase a particular car that is predicted to depreciate at a rate of 6% each year. If he wants the value of the car to be at least $1,200 when he sells it in 2 years, what should the value of the car be when he makes the initial purchase? So we are going to, we're just looking at this each year, so we're going to use simple interest. So our equation is A is equal to P times 1 plus or minus R, all raised to the T power. 1,200, he wants it to be at least that, so that would be the ending amount, so that would be our A this time. 2 years would be our T. 6% would be our rate, so that would be at 0.06. And it's depreciating, so depreciating means I'm going to use my subtraction. So if I plug these values in, I have 1,200 is equal to P, that's what we're looking for, times 1 minus my rate, which is 0.06, raised to the 2nd power. If I go ahead and simplify 1 minus 0.06 raised to the 2nd power, that's going to give me P times 0.8836 equal to 1,200. And when I divide both sides by 0.8836, my principal or my starting amount is going to be $1,358.08. If you have any further questions, we will go over those in class tomorrow.